Good morning, science students, and welcome back to week 4, module 2. Today we're going to be learning about the law of conservation of mass. So the objective for today is by the end of today's class, you'll be able to analyze a chemical equation and determine if it follows the law of conservation of mass. Tomorrow, we're going to take that understanding and go one step deeper into what the law of conservation of mass means and how we can apply it in an experimental setting. You should have already completed today's Explore, which was a PhET, and you should have also completed today's Read-to-Learn to have a basic understanding of what the law of conservation of mass means. Today, we're going to do something slightly different for notes. So let's actually go back and look at the Read-to-Learn for a moment, and then we're going to take notes together. So today, instead of you copying down notes from my slides about the important vocabulary words, I'm actually going to have you create your own definitions because I have already given you enough information to be able to do so. A really key important skill as you become a high schooler and then move into college is being able to read, watch videos, listen to someone, and then create your own understanding and your own definitions. Just copying down notes from someone else doesn't actually mean you've internalized what it means. So I want you to pause my video. I want you to go back to your Read-to-Learn, and I want you to define in your own words what the law of conservation of mass means, as well as what does it mean for a chemical equation to be balanced. I do not want you to copy and paste. I want the language you use to be your own. Think about how you would describe it to a 6th grader, for example. Go ahead and pause the video, and I want you to take 2 minutes and summarize your own definitions in this blank space here. Okay, at this point, you should be completely done with writing your own definitions. Really excited to see the definitions you came up with as I read through my own students' work. Let's take that understanding about what the law of conservation of mass means and put it into practice today, looking at some chemical equations, first as models and then written as chemical formulas. So analyze the chemical equation below. The black circles represent carbon atoms, the white circles represent hydrogen atoms, and the red circles represent oxygen atoms. Okay, so we have our reactants here before the arrow, and we have our products here after the arrow. So it says count the number of atoms for each element in the reactants or products. Okay, good. We've already done this skill last module, as well as when we learned how to write chemical formulas a few weeks ago. So in the reactants, carbon, I see 2 black circles, so we have 2 of them. Hydrogens, I see 1, 2, 3, 4, 5, 6 atoms, so 6 atoms of hydrogen. And then it looks like I have 1, 2, 3, 4 atoms of oxygen. In my products after the arrow, looks like I have 1 carbon, 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms, and then 1, 2 oxygen atoms. Now, based upon this model, does this chemical equation follow the law of conservation of mass? What that's asking is all of the atoms we started with still present in the products? Are they equal to each other for every single element? Remember, matter cannot be created or destroyed, so if we started with a certain number of atoms, we have to end up with the same number of atoms for each element. A hydrogen atom should still be a hydrogen atom. They can't change magically, okay? And if something new showed up, that doesn't follow the law of conservation of mass because it must have come from somewhere. So, carbon, we had 2 carbon in our reactants and 1 carbon in our products. So right away, this does not follow the law of conservation of mass. That carbon can't just disappear. So it means that someone, whoever made this model, whoever wrote this chemical equation, is missing a product. Either there should be an extra molecule of something, or there's an extra compound that they did not keep track of, and they therefore did not follow the law of conservation of mass. Hydrogen, we started with 6. We ended with 8. We got 2 new ones magically? That's not possible. Oxygen, we started with 4, we ended 2. Same thing. So across the board, this chemical does not follow the law of conservation of mass. No. And how do I know? I know because the number of atoms for each element needs to be the same in the reactants and the products. All 3 elements have a different number in the reactants compared to the products. And remember, what this means, you can't break the law of conservation of mass. That's not possible. So what this means is whoever wrote this model or wrote this chemical equation was incorrect in the first place. Okay? Let's move on to another way you can look at this type of problem. So this time, it just asks us to analyze the chemical equation below. It doesn't give us those intermediary steps of counting up all the atoms, and then it asks us, does this chemical equation follow the law of conservation of mass? Okay, so this is requiring us to do the same thinking, except we're having to take a couple steps all at once. So first, in our reactants, let's start there, I have 2H2O. So that means I start with 2H2, so 2 times 2 is 4 hydrogen, and I have 2 oxygen in my reactants. 2 times 1 is 2. In my products, well, I have O2, so that's 2 oxygen, and then H2O, so that's 2 hydrogen and an extra oxygen. So for a total in my products, I have 2 hydrogen and 3 oxygen. So I started with 4 hydrogen and 2 oxygen, and I ended with 2 hydrogen and 3 oxygen. So does this chemical equation follow the law of conservation of mass? And the answer is no. How do we know? Well, once again, the number of atoms, the number of hydrogen and oxygen atoms are different in the reactants and products. Now, go ahead and move on to the check for understanding to answer similar practice problems by yourself. When you're ready to go through the answers, resume the video and we'll go through them together. All right, at this point you should have completed the check for understanding. Let's go through our answers. So for the first one, it tells us white circles represent hydrogen and red circles represent sulfur atoms. So here's our chemical equation. We started with 4 hydrogen in our reactants, 1, 2, 3, 4, and we ended with 1, 2, 3, 4 hydrogen in our products. We started with 1, 2 sulfur atoms, and we ended with 1, 2 sulfur atoms. So does this chemical equation follow the law of conservation of mass? Yes, this one does. And how do we know? Because they're the same number of atoms for each element in the reactants and the products. 4 hydrogen, 4 hydrogen, 2 sulfur, 2 sulfur. Follows the law of conservation of mass. So this is a correct model. This is a correct chemical equation. Now analyze this chemical equation below. N2 plus 3H3 changes into 2NH3. So here we started with 9 hydrogen and we ended with 6 hydrogen. Already I know my answer. We have 2 nitrogen and 2 nitrogen. So the nitrogen are the same, but the hydrogen are different. Therefore, this also does not follow the law of conservation of mass. And how do I know that? Well, just because the nitrogen, that's not enough. Every element has to be the same. So 9 hydrogen in reactants, 9 hydrogen products, that's not possible. There are fewer atoms of hydrogen in the products, so the chemical equation must be wrong or is missing an extra product. Now, we're going to learn more about how this works tomorrow when we go through and learn about how this works when we actually look at an experiment and take experimental data. But this should give you a really solid conceptual understanding of how the conservation of mass works. Go ahead and move on to independent practice and today's mastery check on Edge Elastic. See you next lesson.